Welcome to the bearing bracket model tutorial part 2. Now let's put the fillets down in the floor. I'm going to switch to wireframe because I'm getting warnings about performance. Okay, so we're going to go and we're going to go to home and we're going to see it in shaded mode. See what we got here. Okay, so it looks like we have most of our internal fillets. Now it's time to do rounds. Okay, so we need to do the two big rounds that go on the base before we wrap the rounds around it. And that is called as an 18 radius. So we're going to go back to solid and we're going to put those two on. So we got one here and one here. Okay. Okay, so we got the fillet on one of the ribs. One side of the rib. Let's see if we can pull off the second side. Okay, so we now have both sides of the rib below there. Now let's see if we can get the fillet to transition the other side of the rib. Alright, let's look at it quickly in shaded view. I'm going to save first. Hopefully it regenerates. So we got our fillet there. And we're going to save before anything can go bad. Alright, so the rib itself has all its fillets. And all of the positive features on the model have its fillets. Now the challenges are exterior fillets. Okay, we've gotten the majority of the fillets for this side of the part completed. Now I've had trouble running the fillet that should run around the edge and come around to the top. I believe it's having trouble calculating the transition around this boss and the transition between this boss and the corners. So perhaps order operations. On a previous part, I tried to include the fillet and round with a different stage so that everything that met the same plane and it worked. It didn't work on this part. I am getting an error message that leads me to believe that it's a calculation problem with this build of AutoCAD. Again, do the best you can. We're going to go light on grading when it comes to completeness of fillets and rounds. But try to do the best you can. I was able to get these to develop, and I'm going to wait to develop the one that goes around the base until we do a mirror command on the symmetrical features and see if it wraps around properly around the bottom. Critical ones would be these large ones because you're going to need those for definition. But if you can think about, if you look at from the side view, are you able to define the part correctly in a drawing format? And so try to focus on the fillets that are going to describe the part in your views you're planning to do. So in that context, even like the fillets on this center rib isn't really all that critical. It's more the ones that you can see from the sides. So it'll be important that I can get this fillet here where my cursor is on the finished model. Okay, so pretty much everything I have here is symmetrical. I do want to point out that I think it's a detail you need to pay attention to is the height of this boss is a millimeter shorter on the opposite side. It's hard to read on the drawing, but the overall width is 33 and the projection on this side is 17 millimeters. So that means after we mirror this, we'll need to slice off a millimeter off the overall height of the smaller boss. Okay, and that's something that you need to detail on your drawing so that the person making this part knows that it's not symmetrical. Okay, so when you're ready to do the mirror, you kind of want to try to make sure you have quite a bit done on it when you're doing the mirror of the items that are symmetrical, because once you mirror it, it's hard to go back and make changes on the original. So I've elected not to put the holes in because they're going to go all the way through the part. Okay. If you've been working, make sure you save before you do the mirror. It can be a processor intensive action. Sometimes it is not. Okay, so I'm currently set up with my Y and X plane, and I intentionally drew my model right on that plane, so that way I can use it to mirror the part. So I'm going to be using this XY plane as my mirror plane. There's several ways you can define it. You could also select on 3 points to define a plane. So, I could pick on my construction lines as my 3 points because they happen to be in that same plane. If your mirror plane is not doesn't contact the part itself, you're going to end up with a space in between based off the placement of that plane. Okay, so the command is actually pretty straightforward. You've probably used it before, but you can use it for solids, and we're going to do a 3D mirror. Okay. Actually, I'll hover over that so you can see the instructions. Okay, so we're going to create a mirrored copy of what we have, the objects, by defining a plane. And in their example, there's, I don't know, maybe 50 millimeters between the plane and the part. And so it places the mirrored body spaced away from each other. In this case, we want them contacting each other so we can join the two solids together. Okay, so we're going to use that command, and it's asking for what object you want to mirror, and make sure you've got everything as one object at this point. Okay, so we have one item to select. Okay, and then you get a bunch of options: object, last, z-axis, view, xy, yz, zx, and 3 points. The simplest one I think is actually 3 points, which is defaults to, but because I plan to do this up front, I am going to use the XY plane. So you type in XY, and my mirror plane is going to be 0, 0, 0, 0. Okay, and do I want to delete the source? Now, if I was just trying to make a mirror of this part and then save it off as a different name, different part number, I would say yes, but because I want to keep it, I want to say no. And now we've mirrored the body on the opposite side. Excellent time to save. I'm glad that was successful. It would be painful to try to do all these fillets again. And at this point, you have a couple options. We could shoot the holes through, and the process of doing that would create one body, or we can join them. I want to try to see if I can get the fillets to work. So I'm going to go ahead and join it now and see if that influences the fillets. So we're going to pick on our two entities, and now it's all one. And for these processes, you want to make sure you save. It also is not a bad idea to save off a different version before you do one of these options that are difficult to change. Now, let's go through and let's see if we can get our fillet to work properly on the base. We're going to go to Solid, Fillet Edge, and we want to trace the entire bottom of the part, the top face of the base flange. I apologize for the graphics problem. It seems to be the only way I can get rid of it is to restart AutoCAD. Okay, so at minimum, make sure you have those fillets there. All right, so the next feature we're going to add is we're going to add, actually before we forget about it, we're going to remove the 1mm material from the top of the boss here. So what we're going to do is we're going to use a different command called a press pull. Okay, and what that does is modify an existing surface. Okay, so it shrinks the boss by 1mm, which gives us the print. So if we measure from the face I've highlighted to the opposite side of the boss, it should be a total of 33mm. Make sure you do it on the correct side, because that's going to be something that needs to be called out on the drawing. Okay. All right. Let's save, and we're going to next put the boss on the top of the part, and that'll be the last additive feature. Everything else we'll do is subtractive at this point. Besides attempting to put the fillet on the top of the part. Let's see. Let's let's go to wireframe, and there's a bunch, of course, there's always other methods to do this, but the method I'm going to use is to actually draw the circle in the center on the origin, shoot it straight up to the height that needs to be. Okay, so we are going to go to wireframe mode for that. And we're going to need to change our orientation to our UCS to be working in the top plane. This will allow us to then draw a circle, and we want to pick up on our origin point. And we're going to switch to diameters, and we have a 17 millimeter diameter boss. Okay, so we're actually working inside the part. And now we're going to calculate the height of that. So the overall height of our boss, so from the very base of the part, it's 162 millimeters. But the center of the bore is 133 millimeters. So if we subtract 133 from 162, I'll go ahead and do it on the calculator so you can see it on the screen. So if we take the overall height of 162 and minus 133, we have 29 millimeters between the point where we're drawing this boss and the top of it. So we need to extrude it 29 millimeters. Okay. We're going to accept that. And we're going to go back to our shaded view. Okay. And it should look like that, such. Now I'm going to make the cuts that go through the two bosses, and that function, what it'll do is end up cutting this body and this body, and the end result would be a single union. So we don't need to do the separate union command. You could do it at this point, but here we go. So we're going to switch our viewing plane from the UCS back to front. And we are going to draw a circle, and we need to make sure our object snaps include center, as we want to pick up on the center of the boss so we can draw our first circle there. Okay, our diameter on this is 28.57 to 28.52. So to shoot in the middle, we need 28.52, which is a 0.05 millimeter difference divided by 2. Add that to the low end of the range, 2, and we derive at a nominal size of 28.545. Let's switch the diameter, and we're at about 28.545. Alright, so now we'll go ahead and repeat our circle command boss. And you hover over the edge, you should see the circle, and you should see the center point show up, and then you can select it. Sometimes zooming in and out helps with that aspect. Okay, and our second one is a 13 millimeter hole. It's a plain hole drilled through. So we're going to change to a diameter again, and it's going to be 13. Alright. Okay, so now we're going to use the same technique we've used before. We're going to extrude a couple bodies and remove the material. Alright, so we're going to go to extrude, We're going to select our, and it'd be easier to do this in wireframe so that we're intentional about what we're selecting. And I'm going to go ahead and select both circles. Some people do these all individually so they're separate, but in this case I'm just going to go ahead and do them both. And I'm going to extrude them 35. It'll be just a little bit longer than the actual hole. I'm going to go back to shaded mode and look at the part from the other side because I intentionally made those cutting bodies a little bit longer so that they're easier to select on. And we're going to use the solid subtract command. And again, first we need to select what we want to keep. And we have two bodies because we have the boss shown. And we're going to hit enter. And then we're going to select what we're subtracting, which are the new cylinders we've made. And we're going to hit enter. And what should have happened is you get a nice smooth bore and it chopped off that, and now the boss is now unioned with rigid union with the rest of the model. This is the end of the bearing bracket model tutorial part 2. Please continue in part 3.